So hey guys, today we'll be learning how to solve the square one. And before we get started, I hope you know how to solve the 3 by 3 because some of the mechanics are almost similar to that. So notations in square one are denoted using slices and numbers, or you could say backslash, which essentially means one entire slice. And there are usually two numbers, not usually, there are always two numbers between two slices, and it could be 0 as well, which means no turns. So the first number means turning the upper layer, and the second number means turning the bottom layer. Now for example, if the algorithm says slash minus 1 slash, so it means you slash, then you do minus 1, which is a u prime in case of 3 by 3. So this is minus 1, not the entire turn. This is one segment is minus 1, and then minus 1 in the bottom layer again, which is this, which is d prime in the 3 by 3. Now you might get confused how much is one turn exactly sometimes. So this is basically one turn. 1, 2, 3, 4, 5, 6. So when you turn a corner piece like this is two turns. 1, 2. So just not to get confused with that. So to solve the square one, there are essentially 4 steps. The first step is to make a cube out of this, and then the second step is to solve all the top sides, that is entire white and entire black or yellow in your case, and it goes for both the corners and the edges as well. And the third step is to solve the corners in their particular slots, and same for the edges finally. So the first step, like I said, is to turn this mess into a cube, and by that I mean that to turn the top layer and the bottom layer into a cube shaped. We do not have to focus on the middle layer at all in the starting few steps. It's in the last step, which only has one parity. So essentially, to convert this into a cube, you need to spot the edges which are in pair. So these are the edges, the small ones are the edges, and the big triangular ones are the corners. And so you have to make pairs. Now this is not a pair because it has three of them. This is alone, this has a pair, and these two are adjacent to each other but they're alone, so we won't focus on them. Now you could consider this as a pair if you ignore one of them. Now to ignore one of them, you have to bring them to a slice. Now when you slice this, as you can see, it breaks this, and this is a pair. So now you can put the other pair over here. Now put it to put it here, you have to just turn it once, and these are now in the shapes of 4. So the same thing you have to do for all of them. Now the next step would be pairing these edges up as we paired these. So now these edges can be paired together by doing this. As you can see, these two are paired. Now this cannot be learned just by some algorithms. The cube shape, the formation of cube shape doesn't usually have algorithms. You have to keep trying and experimenting with them, and you you have to find intuitive methods to do them, so it gets easier and you don't have to memorize all the algorithms. So you would have noticed if we try to slice these two together here, you can't do it since the slice breaks over here, and so that's all right. At the end of the day, you have to get all the edges together. So even if you do it one by one like this, now you have 5 edges together, it's all right. Now while we were turning this, the adjacent edge also came with it, which is a good thing because now we have two opposite pieces. Now when we have two opposite edges, it's a good thing because you can slice them easily to the beneath pair, and then you can turn it once, you can turn this twice, and you can slice them up again. So now we have 6 of them together. So now we have solved these 3 edges. These two are remaining. So when the edges are over here, it's a bit complicated because they are adjacent to each other. If these were opposite, it would have been just one slice and it would have been solved. So then we have to pair these over here, or what you could do is put this in the opposite and just make it a one slice solve. So what we can do is these two pairs can replace this, and then these two pairs can replace this. How you can do it like this, you can put it here, you can put these at the back, and then you can replace it. And now when you turn it like this, you can see these both are in the opposite direction, so it's just one slice and all the edge pieces are together. And in the bottom there are no edge pieces, you will get a star like shape. So now we have all the edge pieces together with a star shape in the bottom which has all the corners. And so this is now only a one algorithm, and then you have a cube shape entirely. So your first algorithm for Square-1 goes like this. You keep the all the edges like this, keep it symmetrical, and you can keep this however you want. So you slice, and then you go -2, -4, slice, -1, -2, slice, -3, -3, slice. Now you can see this is back to a cube shape. Now you could get a case like this where your center is not aligned in a cube shape, which is completely fine. For the first few steps you only need these to be in a cube shape. This can be solved in the last. So the next step is to cover all the sides with white or black or yellow in your case. So let's get to it. Now the next step would be to solve all the top layer and the bottom layer sides on the surface. So you can do that by first solving the corners and then the edges. So in order to solve the corners, you could get several cases. Suppose this one where you have opposite corners. So in this, all you have to do is line this up, and then you have this. These are all lined up, and then when you try to slice like this, you see the cube shape breaks. So what you have to do is turn it once, and then you can slice it once, and then you can see that these are now adjacent. So all you can do is line this up in the opposite direction, turn it once, and slice this up. So now you have all the corners solved in both the sides. Now another case you can get is where three corners are solved and one is unsolved. What you can do is line these in the corner, keep the unsolved corner towards you on the left, and keep the piece which needs to come here on the right towards you. You slice it once, and then like this. Now you can see these are again adjacent. You can just put it in the opposite direction and slice it once, and you'll get all the solved corner. Now another case which you can get is you have one adjacent and one opposite. Now you can get this to solve by many steps. There are advanced steps which you could do it in one step, but let's stay intuitive in this one. So you slice it off once, you keep this on your right and keep this anyhow, it doesn't matter, and then you slice once and bring it down, and then you have the old case back. So you can just do this, bring this here, bring this in the corner, and then you slice once, and then you do this again. Now you can see these are lined up, and then slice once, and there you go, you have oriented all the corners. So now that we have oriented the corners, we have to orient the edges. So the orientation of edges work in a progression matter, so where you go from one step to another. So this is the least complicated or the most straightforward case, and it has only one algorithm. You could get more complicated cases such as two adjacent ones, or all four are not oriented. So this can be solved using this algorithm: 1 slash -1 -1 slash, and all the edge pieces are solved. Now like this, there are 5 more cases which I'll be showing you. So this is the next case where you have two adjacent ones on both the sides. So what you will do is keep both of them towards your right, and you do this algorithm: slice 3, slice -3 -3, slice 0, and then 3, slice, and then you have the first case again, and you can do the same algorithm again. That is 1, slice, 1, minus 1, slice. The next case where you get two edge pieces which are opposite and adjacent. So for this you have to keep the opposite like this and the adjacent one on your left. So you solve it with the same algorithm as before, that is slice 3, slice, -3, -3, slice, 3, slice, and then you have the old case again. So you keep it over here, and then you again do slice 3, slice, -3, -3, slice, 3, slice, and you have the first case which you can solve using the first algorithm. Now the next case where you have two edge pieces, one on the top, one in the bottom. So to solve this you have to do the first algorithm. So now you have to keep the top edge towards you and the bottom edge at the left of you, and you have to do the first algorithm, that is 1, slice, -1, -1, slice. Now this is one of the known cases where you keep the opposite like this and the adjacent at your left, and you do slice 3, slice, -3, -3, slice, 0, 3, slice, and then you get another known case where you can do the same formula again, and then you get the first case where you do the first formula again, and then you have all the edges oriented. Now another case would be where you have three edge pieces like this. So again you do the first formula, you keep this towards you and keep these three edges on your left, and you do the first formula, that is 1, slice, -1, -1, slice, and then you get this one again where you can keep this in left, this one in left, and this one on top, and do the second formula, that is slice 3, slice, -3, -3, slice, 0, 3, and then this one again, slice 3, slice, -3, -3, slice, 0, 3, and then the first formula again, and then you have oriented all the edges. Now the last case would be this, where all the edges are not oriented. This is one of the simplest case where you have to do the first formula just twice. So 1, slice, -1, -1, slice, then this is the first case, you keep it like this, and then again 1, slice, -1, -1, slice. Now that we have oriented all the edge and corner pieces and turned them entirely yellow and entirely white, the next step would be solving the corners. So on the top layer, as you can see, these both are solved. How would I know that? You can compare it to a 3x3, and you can see this corner and this corner are solved, and this corner and this corner are solved. They are in like right place, or you can just turn it and you can see these are oriented in the right place. Now we have to solve the other two corner pieces. Now something about regripping. So essentially what you could have is this case where the bigger part is at your left. You could still perform the algorithm, but just to speed solve, what you can do is you can do one slice, rotate it twice, do another slice, rotate it twice, and then do another slice. So what you can see is now these both are big. Turn this twice, turn this once. Now you have the smaller piece on your left, so this is easy to regrip and easy to turn. So we had these cases. Now let's get to the algorithm. You keep the solved edges on your left and the unsolved ones at your right, and do this algorithm: slice, -3, slice, 3, slice, -3, slice, 3, slice. Now you can see, you can compare it to a 3x3. All the corners are solved. And now we turn around and do the other layer. Now here, as you can see, these two are solved and these two needs to be solved. Now essentially, like in the previous step I said, we have to keep this in the right, but what happens when you keep this in the right is you disturb the corners in the bottom layer. So what you have to do is keep the solved ones at the back and do the same algorithm again. So you do slice 3, slice -3, slice 3, slice -3. So as you can see, uh, the corners in the bottom got a bit disturbed, but then what you can do is you can see the solved edges again, solved corners again, put them in the right and do the same algorithm again. So slice -3, slice 3, slice -3, slice 3, slice. Now you have solved the top layer and the bottom layer's corners. Now sometimes you would have come across cases where none of the corner pieces are solved. So what you can do is do the previous algorithm again, that is slice -3, slice 3, slice -3, slice 3, slice. Now you will have the old case where you have two corner pieces solved and you would have disturbed the corner pieces in the bottom as well, but once you do the previous case again, it will be solved as well. So you do the same algorithm again, slice -3, slice 3, slice -3, slice 3, slice. So now you have oriented and solved all the corner pieces again. So now that we have permuted all the corner pieces, the next step would be permuting all the edge pieces. Now you could have unpermuted edge pieces on both the layers. In this case we have only in one layer. So this is the first case where you have 3 edge pieces unpermuted and 1 edge piece which is solved. So this, if you know PLL, this somewhat looks like a U-form where you have these edge pieces unsolved and the last one solved. So what you have to do is keep the unsolved one at your left and you look at the edge and the corner piece. If these both are opposite colors, suppose you compare it with the 3x3, you have blue and green which is opposite, or you can just look at the middle layer which is blue and green. If these are opposite, you do the previous algorithm twice. So you go slice -3, slice 3, slice -3, slice 3, slice, and then you turn it to once and then you do the same algorithm again, slice -3, slice 3, slice -3, slice 3, slice. Now you have solved the top layer. So the next case is similar where you have 3 unpermuted edges and 1 solved one, and this one kind of looks like the U-form again on the 3x3 like this. Now you can see you keep this on the left and you can see these both are not opposite, these are adjacent, as you can see the middle layer, or you can compare it 3x3. These two colors are adjacent, that is red and blue. So what you have to do, you have to do the previous algorithm, but you have to do one turn and then you have to do the previous algorithm again. So that is slice -3, slice 3, slice -3, slice 3, slice. Then you have to put it back in place and do the same algorithm again, slice -3, slice 3, slice -3, slice 3, slice. Now you have solved the top edge again. Now for the next case where all the edges are to be swapped opposite, like a 3x3 edge form like this. So this goes here, this goes here, this goes here, this goes here. So you have to do the first algorithm again. And then you turn once again and then you do the same algorithm again. Now you can see you have got one of the old cases. Now for the next case where all the edges are unpermuted and the adjacent ones needs to be swapped, like the blue goes here and the red goes here, and here the orange goes here and the green goes here. This somewhat looks similar to the 3x3 Z-POM. So to do this, from any of the side, do the first algorithm again. Slice -3, slice 3, slice -3, slice 3, slice, and then you flip once and you do the same algorithm again. Slice -3, slice 3, slice -3, slice 3, slice. So you have the one of the known cases. So you do the known algorithm, and there you go, you have solved the top layer again. So the next case is parity. So parity is any case which is not possible to recreate in a 3x3. So here you can see these two edges needs to be swapped and these two are already solved, which is not at all possible in a 3x3. So you get another case where these two needs to be swapped and these two are already solved. I'll get to that later. So let's do this one first. So the algorithm goes like this: slice 3, -3, and then 3, slice -1, slice 2, 2, slice -2, slice 2, -2, slice -1, slice -3, 3, slice, and you'll get this pattern. What you can do is line the black one or the yellow one or the white one beneath each other and then just swap these two, sorry, like this, and now you have a regular case which we have solved earlier. So now you have solved the upper layer. Parity case is where these two are opposite sides and these two are already solved. So you have to swap this with this and vice versa, which is, this case is not possible in 3x3. So this is called a parity. Now what you can do is bring this case to the previous one, and to do that what you have to do is do the first algorithm again. So that's slice -3, slice -3, slice -3, slice 3, slice. Then you flip it once and do the same thing again. Slice -3, slice 3, slice -3, slice 3, slice, and you have got the previous parity again. So you do it again. Slice -3, 3, -1, slice 2, 2, slice -2, slice 2, -2, slice -1, slice -3, 3, slice. So another case would be where all four are unpermuted, but on top of that, these do not swap adjacent or they do not swap opposite either. They go in a cycle. So you have to find the edge piece which goes here. So orange goes here, so you have to keep it in the right. Suppose it was like this, blue does not go here, so you have to keep it like this. So orange goes here, and do the first algorithm again. And then you have the parity again, so you can follow the same step again. Now after you have solved both the layers completely, three things could happen. The first is you have solved the entire cube, so congrats on that. The second is the middle layer parity. There are two of these. So the first one is this, where this needs to be flipped and put around. So what you can do is, it's simple algorithm. It's not even an algorithm. You can just remember it with moves. So it's slice, you flip it twice, slice, flip it twice, slice, flip it twice. So there you go. And the second one is somewhat similar, but when you try to do the same algorithm on this, you get something like this, which does not work. So what you can do is slice, then you flip it twice, slice, you flip the bottom layer twice, slice, flip it twice, and then you can do the first algorithm again, twice, slice, twice, and there you go. Now you have solved square one.